going to start first off with our rodent surveillance. We have basically our program has two components: the abatement our technicians do, and also the disease surveillance. So I'll start with the disease surveillance. We have two diseases we look for: plague and hantavirus. We find both of them in rodents. I specifically target wood rats so that I can have them tested for both Hana and plague. We also catch like the reservoir we aim to catch the most of is the deer mouse, because that's the main reservoir for hantavirus. With plague, it would be wood rats and squirrels. Moving on to the next component of our rodent program would be our service requests, where we offer inspections. We'll place bait, and we'll also educate the resident on rodent ecology. So what we put out, given that we go to a home and we find all points of entry and they're sealed up properly, we'll put out bait for existing rodent populations. And this is, here's a little cross section, or actually a long section of the bait tube. You can see where they can enter, they feed, and then they'll go out.
And this is the real bait.
And here's the real bait. Yeah. We basically have 4 traps, and each trap that I'm going to talk about is for catching a specific developmental phase of a mosquito. So this one here is for catching host-seeking females. What I mean by that, it's female mosquitoes that need a blood meal. And the way we catch them is, the black canister up there has holes in the bottom, and it's filled with CO2 pellets, carbon dioxide, dry ice. And it plumes out and it mimics an animal with CO2. This is the trap itself. It has a motor and a fan, battery pack. Battery goes in here, rechargeable lithium-ion battery. And basically the mosquitoes will be attracted to the CO2. They'll swarm, and then they'll be sucked into the net. And after that, they're brought back to the lab, knocked out. We ID them down to species, gender, and then, well, most of them are female. Every now and then we'll get some males, and then we're able to pool those. By pool, I mean we take 50 of the same species and submit them for testing for West Nile virus, Western equine encephalitis, and St. Louis encephalitis. So that's for host-seeking mosquitoes. The other trap I want to talk about is called a red box. This is a model. We have small ones also, but the ones we use are 6 foot tall, 6 foot deep, and 3 feet wide. And basically we are able to walk into them and we suck the mosquitoes off the wall, because this actually acts as a little micro habitat, and they're attracted to the red color, and it's a nice place to rest. Because after a mosquito feeds, after a female feeds, she needs to rest and digest the blood meal, and all that blood will be nourishment for the eggs. But it's really a gold mine for us in terms of research, because we're able to get these mosquitoes, have the lab test them, and they can tell us if they have virus and also what kind of bird or mammal they fed on. So with that kind of information, we can pinpoint habitats and find lots of virus and be able to coordinate with our ops and do the proper control. So the way we bait them, we use a attractant. This is a brew we make out of alfalfa. It's fermented alfalfa, and it's poured into this reservoir, and the mosquitoes will come to lay eggs and they get sucked up by a fan. It's kind of the same setup as that, same kind of motor, but just a lithium-ion chargeable battery with a motor and a fan. And we've been playing around with design. We try to think like mosquitoes here, so we were thinking that this is kind of an obstacle for them, so why not put attractant on top? So we're kind of comparing the efficacy with these traps, but these by far are the best traps for getting mosquitoes that are going to lay eggs, and those are the best mosquitoes to test for virus, because if they took a blood meal and it had virus, it would give it time to amplify. And then the last trap This is the oldest trap. This is called a New Jersey light trap, and we need an electrical source. This traditionally was used in rural areas where there wasn't any competing light source, and it works really well at catching any flying insect. So we'll get male and female, and also some other flying insects to take blood meals. We're rearing these out for our public education. We have a guy who'll go and talk to some students, so they like to see mosquitoes and all their different life cycles.
This is water you collected from someplace?
So this water was in the tree hole, but it's been diluted, a 1-to-3 ratio, so it was even darker. And we just keep them in these rearing pens. When they first emerge, the first thing they go for, they want to get their sugar meal, and then if we want to feed the females, we have to give them blood.
Some breeding going on, but not much.
There's a couple.
Hey,
So these are water samples you collected from area ponds and stuff, and
these are the little fish.
These are the mosquito fish that we put in residence ponds and pools and water troughs. You guys can kind of see the size of them.
We put in the water, that might be a better picture.
You should put that in my horse's trough.
Trough. Yeah.
Actually, basically the way we have it set up is one person will drive and another person has what we call a Mariama, and I think I have one over there I can show you, and they'll treat as the other person drives. And then obviously, like I said, we're going pretty slow when we're treating this because we don't want to ruin habitat or, you know, have an accident or something of that sort. But this helps us in those large areas.